Hello, this is One Person Studio here. So this is episode 16 of my series in coding game, where I solve algorithmic puzzles on easy difficulty. So we're going to start with this puzzle, equivalent resistance circuit building. Okay, so I have to use parsing and physics to complete this puzzle. And if I click on parsing right here, it will tell us the details of what it does. So basically, parsing analysis is the process of analyzing a string of symbols, either in natural language or in computer languages. So what's the goal to complete this puzzle? So I need to calculate the equivalent resistors of a circuit containing only resistors. So there's two of them, series and parallel. So this is what the series does. The resistance of resistors in a line is equivalent to the sum of the resistance of those resistors. That's a tongue twister right there. So this is basically the arrangement. So the parallel, so the resistance of resistors in branching paths of the circuit is equal to 1 over the sum of 1 over the resistance of each branching path. So this is what it does. So resistance in parallel will be noted with brackets right here. So a branch can be treated as a single resistor by determining its equivalent resistance. So they give us an example right here, and it should look something like this. Okay, let's solve it. Right, I used JavaScript in my last episode from obviously a different puzzle, and I want to continue using that language. So if we look at the input, so in the first line, it's basically an integer for the number of unique resistance present in the circuit. And the next line, which is the for loop, is basically a space separated name and the integer resistance R of a resistor. That's what it does. And lastly, what this does is a space separated a combination of all the brackets and the names of resistors. That's what it does. Okay, so let's add my own input. Okay, so this is the output. So we need the nearest 0.1. That's important. So this is the constraint: 0 less than n is less than 10, and 0 less than r is less than 100. Okay, so I like this, the first one. So it's basically shorten this, so number of resistors, so we can get rid of this. And I want to make a table for the resistance. Let's do that, and I want to make it const. So basically, what const is basically is a variable that you can't change. So let's do const r equals to object from entries. So basically, what that does is basically an iterable object that contains key value entries for properties and methods, and it returns an object created by key value entries for properties and methods. So let's do that. Let's make an array, which is going to be the number of resistors, and I want to map it. So basically what that does is a function that accepts up to 3 arguments. The map method calls the callback function one time for each element in an array, and it calls a defined callback function on each element of an array, and returns an array that contains the result. So let's do that. And I want to use the hour function. So let's search up what that does. JavaScript. If not, then if I can't find it, I'll explain it. Let's do. No, that's not it. Okay, let's. Okay, this is where. So the left part denotes the input of a function, and the right part the outputs of that function. So that's what it does. Sorry that took a while. So I want to make a const, and I want to make a resistor, and I want to make a resistance again, and I want to read line. So what read line is, basically it reads a line from std input, and I want to split it. So basically, what that does is basically a string that identifies character or characters to use in separating the string. So if omitted, a single element array containing the entire string is returned. So to shorten that, is basically it splits a string into substrings using the specified separator and returns them as array. So let's space that out, and I want to return it. So let's return the resistor and the resistance. So I'll use parseInt. So parseInt is basically a string that converts into a number. So let's use resistance. So that's done. So now I want the circuit as a string. So to do that, oh my bad, circuit as a string. So to do that, we need to use the let method. So we need to use let. Oh, if I can spell it properly. So what let is, so let allows you to declare variables that are limited to the scope of a block statement or expression on which is used. So it's different from the var keyword, because var keyword declares a variable globally or locally to an entire function regardless of block scope. So and let is limited to the scope. So let's do that. And this one I want to use define sub-circuits. I want to use regular expressions. So define sub-circuits. I want to use regular expressions. So let's make a const. So RE, which is short for regular expressions. This is what I want to do. Basically I want to do that, and we're going to do 3 of them. So this is the second one. Use W \W, and now I'll plus it. And finally I want to do this. Okay, that's done. That's what I want to do. Okay, so now I want to use a while loop. So I want to do a while loop. Basically, while there's a sub-circuit, I want to calculate the equivalent resistance, and we place the sub-circuit in the circuit with the calculated value. So let's write while loop for sub-circuit, and calculate equivalent resistance, and we'll place sub-circuit with the calculated value. So to do that, let's start with the while. So while RE, which is short for regular expressions, I want to test it. So what that does is basically it's a string on which to perform the search. So it returns a Boolean value that indicates whether or not a pattern exists in the search string, and I want to test the circuit. So let's make a const bracket resistors, which is equal to circuit dot match, and what that does is basically an object that supports being matched against. So it matches a string or an object that supports being matched against and returns an array containing the results of that search, or null if no matches are found. So let's match the regular expressions. So the second one, I want to make sub-resistance, which is equal to EQ resistance. Basically, EQ resistance. Basically, EQ is short for equivalent. So I want to make resistors, and I want to split it by a bracket. That's it. So let's do R sub resistance, which is equal to sub resistance, and I want to use circuit, which is equal to circuit replace RE sub resistance. And now I want to use a console log to print out the result with a 0-point precision. So basically this. Print out (0.1) precision. So let's use console log pass float. So what that is basically a string that contains a floating point number. Circuit, and then let's fix that. So what that is basically a number of digits after the decimal point must be in a range from 0 to 20, which is inclusive. To shorten that, it's basically it returns a string representing a number in fixed point notation. So let's do 1. And finally, I want to calculate the equivalent resistance of some resistors. That's what I want to do. Just do that. Let's make a function. So function EQ resistance. Basically from there, and use brackets. So resistors, and I want to make parallel. So then I want to return the parallel. So let's do that. Let's indent that. So 1 divided by resistors dot reduce some resistor, and then I'll use the arrow function, sum plus 1 divided by R resistor, and then use by 0. And let's do another one. Let's use the colon. Resistors dot reduce some resistor use the out function, I only use sum plus r, and use the square brackets for resistor, and then lastly use a comma by 0. And I think that should be it. So let's get rid of this. We don't need this. I think that should work. No, it doesn't. So line 14. Ah. Okay, that works. Let's do that again. Okay, that works. Okay, well, thank you for watching this episode, and I'll see you in the next one.